Alright, in this video I want to take my power reducing formulas and turn them into what's called half angle formulas. And really, it's just a matter of taking the square root of both sides and changing what we call the angle. Just like this. Here we go. I've got the power reducing formula for the sine here. And if I take the square root of both sides, well, the square root of sine squared is sine theta, or I'm going to have to throw a plus or minus sign in on one side or the other. Let's throw it in over here. Okay. And then I do something that looks kind of funny, but I can justify it here. This is an identity. This is true for every single value of theta, whether theta is big or small or positive or negative. That if you plug an angle in for theta here, you plug it in there. Well, over here you multiply it by 2. So the angle that's being plugged into this cosine is always twice as big as the angle that's being plugged into this sine. Right? So if I call this angle here, let's call this sine of, let's just say a divided by 2. Okay? Instead of theta, I'm thinking of a divided by 2. Well, over here, this angle, 2 theta, would have to be 2 times a divided by 2. Well, 2 times a divided by 2 is just a. So this ends up looking like 1 minus the cosine of a divided by 2. And this is what I think of as the half angle formula for sine. That is, I have half of an angle. Take a and divide it by 2. Over here I have the whole angle. So again, I think of this in, if I know information about one angle, can I find information about something else? If I know information about the angle A, I can find out information about half of A, right? Quick example here. What's the sine of 15 degrees? Well, 15 degrees happens to be half of 30 degrees, right? 15 equals 30 divided by 2. So over here, if this is a over 2, 15 is a over 2, then a must have been 30. So this is the square root of 1 minus the cosine of 30 degrees. Not 3 degrees, 30 degrees over 2. Now notice, I didn't put the plus or minus out in front. This is, I should point this out here very, very emphatically, that you have to pick. It's not plus and minus. It's plus or minus. It's one or the other, and you've got to decide depending on the angle. Well, if I'm talking 15 degrees, 15 degrees is the first quadrant angle. Sine in the first quadrant, positive. I need the positive square root. If the angle I was plugging in here was a third or fourth quadrant angle, then the sine would be negative, and I'd need a negative here. This angle doesn't matter. It's this one that you're taking the sine of. That's the one that's going to determine whether this is plus or minus. 15's first quadrant. Sine is positive. Take the positive square root. Okay. All right. Actually, I got a number here, I think, because cosine of 30 degrees, I know. I got 30 degree angle. 1, 2, square root of 3. There's my 30 degree angle. So the cosine is radical 3 over 2. 1 minus radical 3 over 2 divided by 2. There we go. Simplify that fraction a little bit and multiply top and bottom by 2. So I've got 2 minus radical 3 over 4 under the square root, or I can write that like this, 2 minus radical 3 all over 2. Okay, there's the sine of 15 degrees using the half angle formula. All right, next I want to take a look at the half angle formula for the cosine. So I'm going to start with the power reducing formula for the cosine, namely cosine squared theta is equal to 1 plus the cosine of 2 theta over 2. And I'm going to do the same thing I did with the sine. I'm going to take the square root of both sides, say that the cosine of theta is plus or minus the square root of 1 plus the cosine of 2 theta over 2. And just like with the sine, you pick. You got to decide. It's not both of them. It's one or the other, depending on what you're taking the cosine of. If the angle you're taking the cosine of is a first quadrant or fourth quadrant, the cosine is positive. If you're in second quadrant or third quadrant, you're going to want the negative sign. Okay. Now, again, like we did above, Usually when you think of it as a half angle formula, you think of this not as theta, but you think of this as theta over 2 or a over 2 or x over 2, something divided by 2. That is, you have half of an angle. Well, again, the relationship in this thing, this is an identity. It's true for every angle. Whatever the angle is here, this angle is twice as big. So if this angle is A, then this angle over here has got to, sorry, if this angle is A over 2, then this angle over here has to be twice A over 2, which would just be A. Right? And this is the formula that I usually think of when I think of half angle formula. Right? As an example, what's the cosine of 15 degrees? Well, 15 degrees is half of 30 degrees. First quadrant, cosine is positive, so we'll take the plus square root. 1 plus the cosine of 30 degrees over 2. Now, it didn't matter if you thought of this 15 degrees as the theta, and now I've got 2 theta, or if you thought of 15 as A over 2, and now I have A. One way or the other, this angle is twice as big as that one. Right? So you went from 15 degrees to 30 degrees, and now I know something about 30 degrees, right? Draw this triangle, maybe you've seen this before. 1, 2, square root of 3, 30 degrees, the cosine is radical 3 over 2. Right, it still is. It was just a moment ago. Huh, funny how that works. The whole thing is underneath the square root, so that 2 is under the square root. I'm going to simplify this a little bit by multiplying by top and bottom by that denominator. So this is the square root of 2 plus radical 3 over 4, which I could rewrite as just the numerator under the square root now. And the whole thing over 2. Right? So the cosine, so what was the sine of 15 degrees was that, and the cosine of 15 degrees is this. Okay, and I suppose there's a tangent we could do as well. The tangent, remember, the tangent had 3 different power-reducing formulas. There was, first of all, 1 minus the cosine of 2 theta over 1 plus the cosine of 2 theta. There was 1 minus the cosine 2 theta quantity squared over sine squared theta, and there was how did it go? Sine squared theta over 1 plus the cosine of 2 theta, that whole thing on the bottom squared. Right? So that when you go to take the square root and turn it into a half angle formula, you've got the tangent of theta is plus or minus the square root of this one, or it's plus or minus the square root of that one. But actually, this one's kind of nice because both numerator and denominator are already perfect squares. So when I take the square root, I just get a 1 minus the cosine 2 theta on the top, and I get a sine theta on the bottom. Sorry, I get a sine of, I got to be a little more careful because these were both 2 thetas. I look back at what I had, these were 2 thetas. So this should be a 2 theta right here. Right? Yes. One thing I gotta be a little careful of is the plus or minus sign, right? Again, here you pick, depending on the quadrant that your angle theta is in. If you're in the first or third quadrant, you take the positive. If you're in the second or fourth quadrant, you take the negative, right? If this angle theta is in those quadrants. And I got to be real careful here, taking square roots of things. You don't always get back to where you started from. If you square and then square root, if you started with a negative, you'll never get back to that negative. But it's going to turn out, and we'll argue this here in a moment, that the plus and minus signs actually take care of themselves here. And likewise, when I square root this, this is sine of 2 theta over 1 plus the cosine of 2 theta. All right. When I think of that, though, in terms of a half-angle formula, I don't have theta here. I think of it in terms like this. So think of the theta as some angle divided by 2. Well, where this is theta, that's twice as big, 2 theta. Where this is a over 2, twice as big is going to be a. So this would look like this, plus or minus the square root of 1 minus the cosine of a over 1 plus the cosine of a. Right? Either theta and 2 theta, or a over 2 and a. This angle is twice as big as that one. And likewise over here, this would just be 1 minus the cosine of a over the sine of a. And likewise here, this is the sine of a over 1 plus the cosine of a. Sorry, my voice is getting pretty scratchy here. So here we go. Notice the sine, the SIGN of the sine, SINE, is going to keep things straight for us. I make the argument here that cosine of a is somewhere between 1 and minus 1. So if I add 1 to it, that's going to be between 0 and 2. So the denominator is always positive. Likewise here, minus cosine of a is somewhere between 1 and minus 1. And when I add 1 to it, it's going to be between 0 and 2. That's always positive. So the sine, SINE, no, SIGN, the plus or minus sign of this fraction or this fraction depends on what quadrant A is in. Well, if A is in either the first or the second quadrant, this is going to be positive. However, if A is in the first or second quadrant and you cut it in half, then A over 2 is going to be in the first quadrant. And so the tangent should be positive. Well, that's good, that's positive. As soon as A gets into the third quadrant and that sign becomes negative, then A over 2 makes its way into the second quadrant. And the tangent is negative in the second quadrant. If A makes its way into the fourth quadrant, dividing it in half still leaves you in the second quadrant. That's negative. By the time A comes all the way around into the fifth quadrant, cut it in half, you're in the third quadrant, and that's positive. Again, tangent is positive in the third quadrant, but if sine's in the fifth quadrant, it's really back in the first quadrant, and that works. So the plus and minus signs actually take care of themselves in this. To finish this video, let's do a quick calculation of what is the tangent of 15 degrees. Well, I can do it two different ways because, you know, up here I had the sine and the cosine. The sine of 15 degrees was the square root of 2 minus radical 3 over 2, and the cosine was radical 2 plus radical 3 over 2. Invert and multiply, the 2's cancel out, and I've got this funny looking thing that looks like 2 minus radical 3, radical 2 plus radical 3. And that would be the tangent of 15 degrees. However, I think I can get a little bit nicer by actually using one of these things. I'm going to use this one. I could also say that the tangent of 15 degrees is 1 minus the cosine of 30 degrees over the sine of 30 degrees. And these are nice numbers. Cosine of 30 degrees, right? Cosine radical 3 over 2. Sine of 30 degrees is a half. If I multiply this one top and bottom by 2, I've got 2 minus radical 3 all over 1. So apparently, this funny looking fraction is equal to 2 minus radical 3. It's not at all obvious. You might try typing this into your calculator, typing that into your calculator, see if you get the same thing. You should. Anyway, there's your half-angle formulas.